Yeah, okay, so let me just briefly introduce myself. My name is Oliver. I'm Chief Data Scientist at EODA. I will say a little bit more about EODA in the next slides as well. Yeah, I'm a data scientist, and I think I'm one of the earlier generation data scientists. So I started to become a data scientist when the term data science wasn't actually around. So my personal background is social science, actually. So I didn't do any computer science or statistics, but I did social science. And as part of this study program, I was trained in statistical methods, and this was the starting point of becoming a data scientist. Well, actually, most things I do in my everyday job, I didn't learn at university. This has changed, I hope, at least in the last couple of years, but that is my personal background. Sorry. Yeah, just some quick facts about EODA. I have founded EODA with a co-founder in 2000. I founded EODA in 2010, so that is quite old for a data science company, I would say. We have about 50 employees, about 200 customers. 14 of them are part of the German stock exchange. And we do a lot of training, actually, and we had over 1,700 participants in our training. So we did a lot of data science, and we have a mission, and this mission is add value from data to value, so to speak, by using kind of knowledge transfer, by being transparent, by explaining what we do. So our mission is not to put kind of a black box AI module somewhere, but we would like to empower our customers to do data science. So that is kind of our overall vision. And as a final slide on our company, we have 4 main pillars. And one of them is actually strategy. And maybe I can explain a little bit more why we decided to introduce data science design sprints into our portfolio. It is a relatively new portfolio element. So it's not the case that we do this since, I don't know, 5 years or so. We just relatively recently added this component to our portfolio because we made the experience that this is something which is missing, and that a design sprint can solve, especially the very early phase when you go to proof of concept projects, when you want to design an MVP. But just to give you a brief overview about those pillars, the green area is our project area. So we do kind of MVPs projects, we do operationalization, but we also help finding use cases and finding strategies. We have a strong training part, that's the orange sections. So we do kind of technical trainings, but also management trainings in terms of, you know, what are the chances and of data science, and what do we need to do in order to put it into your company, so to speak. We have an aspect of infrastructure for data scientists. So this is especially useful for companies that have a larger team of data scientists and that want to have an infrastructure where they can build production-ready data science, data products, and data science code. And we have a software called Juna, which helps to combine data scientists with domain experts in order to create models that are kind of not only built by data scientists, but also from insights of experts, because we think that the domain expertise is extremely important in the realm of data science. Yeah, that's as a general introduction to myself and to EODA. So now I would like to come to our main focus, data science design sprints. So what are kind of the main aspects of design sprints? First of all, it's an interdisciplinary team of about 5 to 10 participants. This is just a rule of thumb. So I mean, it's okay if it's just 4 or if it's 11, but it turned out that somewhere in the area of 5 to 10 participants is a good number of people. And it is really important that this team is interdisciplinary. That means that there's somebody on the table who knows everything about the data, who knows everything about the business. And also, of course, we need people who knows everything about data science, so that we have all stakeholders on the table. As the name sprint suggests, a data science sprint is relatively short. It's usually 1 to 2 weeks. And the idea is maximum sprint. I mean, in a sprint, you cannot go for a sprint for, I don't know, 1 hour or something. It is just a limited number of time. You want to be quick, but you want to be maximized focused. So it's not only a question of speed, it's also, and maybe more importantly, a question of focus. Yeah, so you get speed by focus, and it is not possible to get speed without focus. We are not in a data science design sprint. It doesn't matter which tools you are using. So it's actually the case that you are using different tools, or that you are using the tools that are kind of your tools that you use in your everyday business. You shouldn't be too kind of pre-decided in the tools that you are using. It contains design thinking elements. So it has also an aspect of, say, if I look at Martin's board, that is pretty common for data science design sprints as well. You have an analog board, and in the best case, I mean, nowadays it's a little bit harder to use analog boards. But these analog design thinking elements of using stickers, of having kind of everything on a analog board, and in the best case, is also typical for design sprints. And kind of from the history, it became famous by Google Ventures, and it is not designed for data science problems. It is designed to solve whatever business problem actually, but it can be applied pretty well on data science problems. So that's why we decided, okay, it makes sense to put this on these kinds of problems. And why did we do this? So why do we think that data science design sprints are a good idea? First of all, we experienced that a proof of concept stages in a project in many cases takes relatively long. You have a bunch of stakeholders. Data needs to be prepared. You need feedback from the domain experts, and this usually takes quite a long time. So it's a very long process in many cases, and it's much longer than it needs to be. So that is one of the reasons. It's too long usually. Data science design sprints put the idea of failing fast to the extremes, so to speak. So you want to be after the design sprint is ready, you want to fail, or you want to say, okay, the results that we have achieved so far are good enough. We want to continue, but at the end of the design sprint, you want to take the decision whether or not you're going to continue the project. And it's absolutely okay to fail, but you want to fail as quickly as possible. Usually you have, if you don't do design sprints, if you do proof of concept as a regular project, so to speak, there is often kind of a lack of commitment and understanding of the complete process by all of the stakeholders. And that is problematic in many cases. There's in many cases no clear starting point. So the point where we say, okay, now the proof of concept starts and now it ends is often not so clear. It's often kind of a floating start point, so to speak, and also sometimes a floating end point. Am I missing? Oh, no, there's something ringing. I don't know if you can hear this. Let me just, I don't know. Can you hear something else than my voice? No? Okay, that's good. Okay. All right, I'm sorry. And finally, there's a low experience in data science by many domain stakeholders. And with the help of data science design sprints, we want to kind of introduce the knowledge of how to do data science also into the team. So this is also a learning and training for non-data scientists to do how to do data science and how data scientists think. That is the general idea of why we do it and why we put it on our portfolio. And a data science design sprint is divided into different days. So the usual length is 6 days. A day is not meant to be it can be like 2 days or 3 days, depending on the issue. It is more kind of, a separated part, a process of 6 steps, which usually takes somewhat around 1 day, maybe sometimes more, but that's not, it's not literally 1 day. So yeah, the first day is actually not day 1, but it's day 0. So in the first phase, we design, okay, what shall be the result of the sprints that we are going to target? Which data sources are generally available? So which is the data that we can access? Which kind of physical or business problems in the physical world, where do we have data for, or where's data lacking maybe? Which competencies in our teams are available? Which technologies are generally available? And we do a kind of a plan of what are the objectives, what are the expectations from everybody, just like we did in this session. And yeah, we do a general planning of the next day. So that is the first phase, the planning phase of the design sprint. On the next day, okay. The next day, day number 1, is about learning and understanding. So as I said, in many cases, like the customers where we do data science design sprints, as a service company, they usually are not too much into the details of data science. So we start with explaining what is that actually, what is data science, what can data science do, what can it not do, where are the borders, what are the limits, what are the chances, what are the possibilities, and what are kind of the general conditions of for a data product that we want to receive at the very end. And so this is kind of a general learning for everybody to have kind of a similar starting point, and everybody knows, okay, what's possible, what's not possible. That would be day number 1. So we don't do anything in day number 1. We just kind of try to learn and bring everybody on the same knowledge base, more or less. In the second day, we identify and prioritize ideas. So the business usually has a lot of ideas. What can be done? What could be a good idea? And after we have set a general mindset on how data science works, we now want to focus on the problem. So what is the problem that we would like to focus on? What is the business issue that we would like to solve? And so this is an idea generation phase, so to speak. Once we have prioritized our use cases that we want to work on, we're going to specify and plan the very detailed use case that we would like to work on, and we ask what is the relevant data for this use case. It's a different question than what is the general data available in the company, so to speak. Now the question is, what is the data for this specific use case? We identify the relevant stakeholders. So do we have everybody on the table, or is there somebody missing? We identify the technical infrastructure and the requirements for the further steps. After that day 3, we sometimes have a break where we kind of organize the data. Sometimes it takes some time to organize the data before we can continue to actually work on our project. So the day 4 is about developing a prototype, and a prototype really means prototype. So we just want to create something as a MVP. We decide for the methodology, for the tool sets we are going to use for the data. We need to do some data cleansing maybe beforehand, and then kind of it becomes more clear what the solution is going to be. And on day 5, we actually train and validate the algorithms that we are going to use. So we have decided for a specific model. So we're going to train this. We let the algorithm learn. We do the hyper parameters of the model, and then we kind of create the outcome of the model. I mean, it's of course depending on the given use case what exactly we are doing, but the general idea is that at this stage we are actually training the model and doing the statistic job, so to speak. And on the other hand, we create a user interface. This is of course very simple, can be an easy interface. We just want to create something as an MVP, as I said, but we want something that somebody can use. You know, that's the final goal, that at the end of the data science design sprint we have something that we can use. Yeah, and finally on day 6, we kind of combine the analytic part and the interface. You know, depending on the use case, the interfaces might look somewhat different, but this is the part where, you know, the interface and the algorithmic backend, so to speak, combines. We think about kind of real customer journeys. So how might this look like in a productive environment, without actually doing it, of course, but just to think about how would a user actually use it in a matter like we would do with user stories. And then we just we create the roadmap. What would be the next step to achieve the next milestone for going live? And of course, that's not on the slides here, but we decide whether or not it makes sense to go any further. So does the use case and the things we have developed meet our requirements that we have defined before? And with this, we can take a decision whether or not we will continue, or whether we really have to say, okay, it doesn't work out as we have expected, so we have failed, so to say, and we don't put any energy in this use case anymore. That's a little lag. Okay, so to give you some general recommendations about how to apply data science design sprints into kind of real-world scenarios. First of all, of course, like more or less always in life, it's good if the problem is clearly described. So if it's a clear problem to everybody, which is good handleable. We would like to reduce the external dependencies, and one of the most important external dependencies is the provision of data. So so where does the data come from? And needs to be very clear, and we want to work with a kind of dedicated data set that is available. We don't want to use APIs for databases. We want to have the data available to use, and this is it's easier if the data is clear, that can be used for this use case. Yeah, and a short-term implementation is required for data science design sprints. Okay, I have a little lag in my PowerPoint presentation. It's not only the video, it's also, okay. Well, yeah, what are the general benefits? It's data science design sprints are actually the fastest way from an idea to a data product, or at least to the first step to the data product. You don't have a data product after a design sprint, but you are on the way to go there, and it's the fastest way to get there. You get really high commitment of all the stakeholders. It's an interesting experience for everybody to learn how data science work and think, and this is really useful also for kind of implementing data science more in general terms to a company. It is relatively low cost, and at least you do have some cost control because you know exactly how much energy you're going to invest for this design sprint, because you have a clear time box where you have to finish your sprint. You gain knowledge, so it's a learning experience for everybody. It's not only that the domain experts learn about data science, it's also that data science learn about the domain. So it's really a learning experience for everybody, a deep dive for everybody into data science. And as a final point, it's fun. It's really fun to do data science design sprints because of this focused work of an interdisciplinary team. Yeah, that's all I had to say in my presentation. Thanks a lot for your attention so far. And if you have any direct question to this presentation, you can ask them just right now. And for a general discussion, we have discussed before this this workshop, and we would like to go into the deeper discussion after the second presentation, so we can kind of get a general discussion afterwards. But if you have any kind of questions regarding the presentation, if anything is unclear, please feel free to ask. Thanks a lot.
Thank you, Oliver, for this nice.
Thank you very much, Oliver, for sharing your approach with us. Very exciting. And I agree with you totally. It's a lot of fun to do such design sprints or data sprints.
Yeah.
Alex has a question. Alex, I see your hands up.
Yes.
Please unmute yourself. Yeah.
Thank you for this nice talk, Oliver. It sounds like fun, but day 5 sounds like the most critical, where you do the training and validate. And I could imagine that there are a lot of surprises come in that day. So I was wondering, do you have some sort of buffer there if things go as planned? Because that's where you're actually doing the work, and that's where usually things go wrong.
Yeah. Yeah, I mean, the approach we just have outlined is, it indicates or it suggests that is a kind of a straight line from day 0 to day 6. That's not the case. I mean, data science is an iterative process, and it can happen that when you build the model, you might find out that you need some extra data. So that is kind of common, but we try to avoid like too long and too intensive iterations in this process, and it would be we don't strike for the perfect solution, so to speak, but we would like to have a first solution that can be after the data science design sprint refactored. So yes, it's not a straight line, it's an iterative process. But on the other hand, I think it's wise to not go too much into these iteration details, and it's better to have kind of a good solution at the end of design sprint than kind of a perfect solution 1 year later. So there are more iterations to come on the issue, and yeah, the goal is to have something at the end, not necessarily the perfect solution.
Thanks.
So Tobias, your hands is up. Would you like to speak? There are also questions in the chat.
Yeah. So maybe one short question for you, Oliver. Thanks for the nice insight. What about group size and let's say staffing from the skill set side? What's your experience with that? Because I think especially for the real working days, you need at least 1 data scientist, and let's say, hacking person, because otherwise you won't get anything done. But if the tech people are too many, I think this will also be problematic, right?
Yeah, absolutely. Everybody needs to be on the table. You need to have at least 1 or 2 domain experts, business experts who know everything about kind of the underlying business problem. You need to have 1 or 2 data scientists. You maybe need data engineer specialists also. So you really need everybody who's necessary to solve the problem. And everybody is always on the table. So even in the phases where you have more, say, the model building phase, the business people also should be still on the table, because then you can kind of quickly do some iterations and find out if there's something kind of from the domain expertise that can be added. So it should always be somebody at the table. And if we have 1 or 2 from each domain, then you end up with, say, 6 to 8 people usually, and that's, I think, a good size.
Should we also answer the questions on the chat, or should we?
Nizamuddin has a question. Nizam, would you like to tell it yourself, or I read it?
Yeah, my question was, in such a short amount of time, like, how would you come up with different models? Like, what sort of sanity test would you carry on? I mean, it is based on your previous, like, past experience, like what sort of models, and yeah, I just wanted to know about that.
I mean, this is hard to say in general. It depends pretty much on the problem. So maybe as a general recommendation, I would go for models that are easy to interpret in favor to kind of models that are hard to interpret, but it depends really on the problem. So we are not pre-decided for any kind of algorithm that we're going to use. It's really depending on the business case, which model we're going to take. But it's also, I would say, not too important if you find the very best model, or if there's a better model. It's more about kind of having a good strategy how to tackle the issue, and in the next iteration you can improve your model still. But you want to kind of once have this road from the business problem to the solution, so to speak, set up, and you shouldn't mind too much about which model you're going to use.
Yeah, let me also share one experience I had a lot of times during workshops or data sprints, and that relates to the question before, because often we learn when we talk about the model that the selection of the right model comes from the business people, because they, for example, have this requirement that they need insight into how the model made a scoring or prediction. And then you instantly can say, okay, all the black box approaches we can remove from the option table, and we just focus on white box models. And so this is also one example why it's really important to have data scientists, domain experts, business people, at the table, at the same table.
Thank you.
Should we also take the second question, Afi?
Yes, Elena. Elena is asking, which approaches do you make use of in day 2 to identify and prioritize the use cases? Did I say everything? Elena, would you like to add to it?
Hi, yeah, no, that's correct. So yeah, what kind of approaches you use, mainly from both the business, to evaluate the business value and also technical perspective? How do you choose?
Yeah, so you have to find a quick solution, and we use magic estimation. And that is a technique that has on the business value and effort on the 2 axes. And then you just make a quick guess. Where do you put the given use cases, and that's a good first estimate to decide for use cases. For design sprints, it shouldn't be too complicated use cases, of course. Yeah. I mean, it's often the best thing. I mean, we do data science design sprints with companies where kind of they have just started to do data science. It's in many cases companies that are not too experienced in that field. And for these companies, it makes sense to, to start with the low-hanging fruits. And that is also an important evaluation criterion. Is it easy to implement? And a third criterion is, if we have implemented this use case, are there other use cases relatively similar to that can be kind of created from that use case as an addition, so to speak? And this is a third evaluation criterion. But magic estimations, in our experience, are a very nice way to quickly assess, to quickly evaluate different use cases from different fields.
Yeah, there's also one more method. It's called the pick method. So it's about picking the next best use case. I sent you a link in the chat. There's a good description on the web how this pick method works. It's an acronym for a possible, implement, challenge, or kill your use cases.
Yeah, and these are the aspects of design thinking and methods that you can use for data science design sprints as well, right? Yeah,
I think we should continue with the next presentation. I mean, there will be further questions, but maybe then we have the chance that two speakers will answer to the question.
Yes, very good point. Also, a joint Q&A would be interesting. So, Daniel, ready to share your screen? I would like to ask Oliver, please.
Yeah, I have to unshare first.
Yeah, as soon as Oliver unshares it.
How do I do that?
Okay. While I start sharing.
We see it.
Perfect. So thanks for having me tonight. I designed this session together with Oliver. I know Oliver now for quite some time. I think it originated in a training I took with EODA. I think about 5 years ago, so along those lines. And since then, we had a couple of business interactions with my companies. I've never worked for any kind of consultancy. I'm coming also always from the corporate side. So, and today I'm talking to you about how we actually utilize this kind of design sprint. It's called a little bit different for us. We designed this actually independently of EODA about 2 years ago, but in our current collaboration with EODA, we figured that we have very similar approaches. So the idea is now to talk about actually applications of those sprints and experience and some anecdotal evidence to get to know this method a bit better. Also the pitfalls we encountered on our journey from a very application perspective. I called my talk today "Forged with Data" because our method is called Data Forge, we introduced this machine learning technique project to our industry, which is not a tech industry. I don't know who of you knows Covestro. I will introduce it in a second. And again, I learned something new about Oliver today, that he's a social scientist by training, and actually so am I, which is a actually funny coincidence. So maybe a few words. Yeah, this is something my company made me put in the slides. So there might be forward-looking statements in my presentation. So they are based on current assumptions and forecasts made. They can change, so please bear that in mind. But yeah, now next thing is about me. So as a social scientist in college, I predicted voting behavior. And when I started my first job, I said, okay, I was asked, why am I going to join data science? Yeah, I predict voting behavior. Now I predict consumer behavior. How hard can it be? So it's basically predicting one or the other with data. Actually, it can be very hard. I call myself a data tinkerer because even though it is a quite scientific approach, I think that this tinkering with data is one of the essence of our job. And so that's why I wanted to highlight this. But also is the fun for me in data science. And I listed a couple of topics here that are near and dear to my heart. So the first one is data to value. I think data science has nothing to do with just doing fancy stuff, but if you don't produce any value, whatever this might be. And I do care a lot about data literacy. So I think a company that introduces machine learning and data science and digitalization in general needs to be data literate. And with that, I mean, not only the data scientists need to be very knowledgeable, but I would go as far as and say each and every employee should know at least the basics of data. To actually value the outcomes of such projects. This is lots to do also with my third point here about explainable AI. I think we as data people, we need to make a good job in explaining our outcomes and how we derived those conclusions in order to gain trust. And especially if you're not in a tech company, you need to gain the trust of your colleagues in order to be actually successful. And the last point is more something of my time if I don't work at Covestro and still do something with data. I like to apply it to sports and esports. I think this is a fascinating field to do machine learning also in our free time. Actually, probably there's some or a lot of value for sports teams in as well. But I do it only for fun. Enough about me. Few words about my company. Covestro is a leading in the world of plastics, as it says. We are actually one of the 14 DAX companies Oda is working with. We are quite large. We have about 17,000 employees. We produce foams and plastics and for many different applications. So for example, if you buy a mattress at IKEA, the foam inside is most definitely from us. We are producing dashboards or the raw material for dashboards in cars. We are producing the plastic for, again, the raw material there for headlamps with cars. So very different applications worldwide. And about 2.5 years ago, almost 3 years ago, advanced analytics was introduced to Covestro as a function. And I try to summarize here what we do. And you find a lot of what my personal preferences are in this slide as well. So it's about increasing data literacy. So we're working with people, combining all those different data people at this large company, and also develop those who are now interested in data to become data analysts, citizen data scientists, however you might call them. We want to provide the infrastructure with kind of a platform where you can actually work as a data scientist, do the data forges, and in the end, our third pillar is the profit. We want to actually do data science, and I just listed a couple of overview projects we are doing. I think there's nothing really fancy or specific at the moment there, because it's a very high level overview what we are doing. And we, as I said, data to value is not only important to me, but obviously also for our company. So how are we as Covestro envisioning a data science use case to be productive and create value? So it starts with an idea. We understand the problem, how actually value will be created, ideally with a one-pager, so with a problem statement and with kind of some value potential. And we actually prioritize based on this as our advanced analytics group. And then we go to the experiment phase, which is our data forge. And you already heard this fail fast. We actually committed on 5 days. And these 5 days are 5 days and not more and not less. And we defined 3 outcomes here, and I will come back to those later. Ideally, the outcome is positive, and then we try to ensure maturity and bring it into production. So we deploy it, we set up the model monitoring, and ensure auditability, which is for such a large company very important, and also has an impact on the models chosen, by the way. And then hopefully a model comes into operation where we actually then benefit from it. So it's utilized in the business processes. We review the model performance and obviously have a CI/CD pipeline ready. And to be fair, the blue box at the bottom, there are use cases that are dropped or paused because the results were unsatisfying or because the business priorities shifted. So fail fast. John Cage said, nothing is a mistake. There's no win and no fail. There's only make. And this is the spirit of data forges or data design sprints. Quite. Because we pretty much very early learned there's an exception for Stream. I don't know whether you ever worked with Forstream. You don't want to fail with Forstream because the results are just disastrous. So again, this is something why data forges are so important, because you don't run through a lengthy POC and then fail or have a more disastrous outcome. But yeah, if we go through the stages and follow our data forge, here are 6 main components of our data forge. And again, you might see find something familiar from Oliver's presentation here. So we are strictly time bound to 1 week, so 1 working week. Without distractions. So we only focus our work on this task, and we expect our business partners to do the same thing, to dedicate the full week to this task. That ensures that we have enough buy-in from our business partners that are committed to a project and don't throw just projects over the fence and say, here, crazy data guys, work on this while we're doing our stuff. No, they need to commit to this as well. It is an agile method, and so it's an agile sprint. And we figured that it is vital to have a Scrum Master. So one person who is not full-time in the Data Forge will be the Scrum Master and do daily check-ins and ensure that the team is actually focused on this week, because we figured that as you tinker with the data, you get sidetracked quite easily by a path that might not be fruitful anymore, and so and you realize too late that you're just lost here. So the Scrum Master here helps to check back. What are your goals? What did you achieve? Why did you follow this path and not a different path? Is it worthwhile continuing there, or is it worthwhile changing directions? All is in a collaborative development. So we are not producing black box solutions. As a non-tech company, I need to say random forest is often just good enough, because random forest has some kind of a sweet spot between explainability and interpretability. My heart as a data scientist or data tinkerer often wants to do more and more complicated stuff and more, for me, interesting and challenging stuff. Experience says from the business is often just satisfied with random forest, which is a little bit sad, but we are getting there. I mean, this is also some kind of data literacy. As soon as everyone knows about random forest, you can move on to more complicated and elaborated methods. We do have actually a dedicated room. So the Data Forge is not only a concept, but it's also a room, because we figured to stay this focus that Oliver mentioned. It's not very helpful to be at our desks and or in some kind of meeting room you might change in between. So we set up a full room only with all the equipment we need, with manual whiteboards, with digital whiteboards, with Kanban boards, with actually very powerful workstations, so that if we have an internet breakdown, we can still work. We can work in the cloud. But yeah, this is one dedicated room. If there's no pandemic going around, we usually utilize that. We require the subject matter experts to be with us in this room for the full time, as well as us, obviously. So it actually turned out, and I can speak here from experience, that the focus on this Data Forge is much higher when you have this dedicated room. So we did Data Forges during the Corona pandemic. It worked remotely, but it's just not the same. So in terms of focus, this proved to be really beneficial. And the last point, but probably the most important point, is about data. And I want to spend a couple of minutes speaking about data. I call it here readily available. If you want to have results in 1 week, you need an almost perfect data set at day one. That's our experience. So in preparation of those data forges, we actually spent quite a while to prepare this data already. That as few as possible changes needs to be made during this week, because you really spend time in preparing the data in terms of data wrangling, but you need all those, let's say CSV files be ready in advance and not start thinking, where do I get this data? Sure, sometimes you need to adjust and get new data, but your corpus, your basic data should be readily available, and that you can start with your descriptives as soon as possible. Because as we all know, data wrangling and data preparation takes up most of the time. And if you consider this 5 days, starting with the data at day one is working with the data is really important. Then you have the chance to start modeling at day 3, maybe day 4. And then day 5 is usually dedicated for wrapping up the results and starting the presentation for the stakeholders. I can briefly, hopefully, switch screens. Then I can show you what kind of templates we are also using to organize this. This might be of interest. We're utilizing Miro for quite some extent, and we have a template folder here with all the necessary things we start before and while data forge. So we start with a one-pager, as I told you, which is a more business-oriented description of the problem and the benefits.
Daniel, can you zoom in a little bit?
Yeah, sure. It is not that interesting because that is at the moment very empty, because it's just an empty spot here where the one-pager shall be. We then utilize a method which I find really helpful to structure your problem is the machine learning canvas, which we fill in either prior to the data forge, which are the green tasks, during the data forge, which is the blue ones, and after the data forge, which is the red ones or the orange ones. So this canvas is it's not an invention from us. We just utilize it. This really helps to structure the business problem into a machine learning problem, and always keeps us focused also on the middle path, the value proposition, because that's what we want to actually achieve in the end. What we also do prior to the data forge is list all the data sources and where to get those. And we try to actually do a very simple ER model also in advance, that we know how this data actually relates to each other. So this work should be done prior to the data forge. During the data forge, we usually start again with design thinking and agile method with our expectations, which is filled out then by each participant. And maybe this is the time where I can also say how we usually structure it in terms of participants. We usually have 2 data scientists in the data forge and 2 subject matter experts. 1 Scrum Master, as again, Scrum Master is not full-time, but it is a dedicated role, so none of the data scientists or subject matter experts should be the Scrum Master. And then, as needed, 1 data engineer. Sometimes you have a couple of more subject matter experts, but this 4 to 5 is kind of the sweet spot we encountered. And during the week, we are trying to structure ourselves with this timetable, the sprint board, where we try to define the tasks for the day. We always set one topic for the day, and then we plan our day with yellow sticker notes what we want to do. And with red, what we need to clarify. And as soon as we basically did this task, we switched the sticker note to green. So it's a simplified Kanban board for a day. And maybe one thing that is quite important is we set a weekly goal. So we have a clear hypothesis for this week, and 1 to 2 sentences that describe what we want to achieve during this week and how all those overarching topics for this week should be actually buy into this. Yeah, and then again, some agile working stuff, some retro with start, stop, and continue, which helps us to modify this process of a data forge. We have gone through quite a few iterations of this, and at the moment we are at a point we are actually quite satisfied how we set this up. Yeah, with that I am at the end of my presentation. I will switch back to my PowerPoint that you can see my contact if you have any questions regarding this. And now I'm looking forward to a lively discussion.
Oh, wonderful. You're muted, Martin. Thank you so much for sharing this. So insightful.
You're welcome. I think it's a great concept, and I like to talk about this because I prove to be very valuable.
Thanks also from my side. And by the way, you find all the presentations also on the Miro board, and also I think Oliver uploaded some additional stuff. I uploaded some additional stuff like a canvas and info link to the PIC method. And Daniel, one thing I wanted to ask you: this machine learning canvas, is it available as a Miro board, and could you share it also with us on our Miro board?
I can share this with you. I can put it in the Miro board. It is available free on the internet. Louis Durand actually presented this method, so that's where I got this from, and I built it as a Miro template from his one. So either look for it online, Louis Durand. If you want to have it as a Miro template, I can certainly put this in our Miro board here.
Yeah, it would be really good if everything in our Miro board is as a handout for all the guests that joined us tonight. They have
I also added the link already to the original one.
Awesome. Questions? Something you want to know more?
Can I ask a question? I don't know, Daniel, if we have talked about this, but maybe it's interesting to get an idea if when you start a data forge, so you have now we have kind of finished a couple of data forges already with different use cases. So what is just roughly speaking, the ratio of the ones that failed and the ones that succeeded?
This might not, I mean, we did a couple of data forges. I said we have 3 different outcomes. So we have fail and success, and we have actually a third outcome, which is let's do this again. So let's do this again is we figured during this week with the data at hand, it's not working, but we gained insights that new data might work. And we already have an idea on how to actually achieve this. So let's do another one. So I guess maybe we were lucky, but we had a success rate of about 60%. We had another 15 to 20% that actually went to the second iteration. And then the rest 10 to 20% rough estimates that actually failed. But we were quite lucky that the failure rate was lower than expected.
I think there are also questions on the chat.
Yeah.
Should I read?
Yeah.
Byron is asking, thank you for your presentations. It's not possible for me to use my microphone, but please consider the following questions. So for Mr. Bracht, as the requirements and business needs of a product or venture grow, there comes a time to start considering more complex data pipelines and build supporting infrastructure leading into the responsibilities of data engineering and DevOps roles. Would you have any tips, tricks, insights, or ideas how to approach the transition to such development challenges? So that's the first question, and maybe then later I read the second question. Mr. Bracht.
Yeah, thanks. That's an interesting topic. I mean, with data science design sprints, we are on a very early phase when we talk about kind of a model lifecycling. But of course, once we have found out that the model is working and it is interesting to put it into production, and you need to create some kind of pipeline. And so I have a few recommendations on this. First of all, it makes sense to think of how to put it into production at an early stage. not because you want to do something about it, but this might also be a decisive factor for which models you are going to use. Because there might be some requirements coming from the production perspective, and it's really useful, and it makes sense to get this requirements also in the design sprint. Yeah, and secondly, in many cases in companies that we're working with, it's a combination of IT operations and data science. And I can really recommend to get these two groups as early as possible in one room, because there's a kind of maybe a historic a clash of, they have different interests. IT operation people want to have a stable system that always works, and data scientists want to have an agile system that always changes. And well, that is both perspectives have their pros and cons, and the earlier you get the IT operation people into the team and on board, the easier it is to actually put it in production later.
Yeah, I fully agree. That's why you want to avoid the famous POC trap.
Yes.
Operations and innovation are in a conflict. So then the second question was then a similar one for Mr. Schulz. What would be some best practices when moving models to production? I think, Oliver, you already had given some tips. What tools would you recommend? TensorFlow, Extended, Kubeflow, TalkSurf, and why?
Oh, tough one. Maybe I first second what Oliver said. I think it's this is really important. What is equally important is a buy-in from the subject matter experts. When we do, I was talking about failing, or no, I was talking about the blue box with the stopped and paused use cases in my presentation. Those usually happened if from the beginning we didn't have a clear path what to do with the model. And this has to come from the subject matter expert. They must need to know, if we do this, I will utilize this in my daily process in such a way. I need a dashboard, I need an API, or whatsoever. You don't produce this during the data sprint or data forge, but there needs to be this business need that they demand. That it's not only the crazy data guys who want to do some cool stuff with data. Maybe that's a more general advice. In terms of tooling, it really depends on your setup at your company. We personally went for Kubeflow as a pipelining tool there, but there is no general recommendation. I would say there we tried Metaflow, we tried MLflow. It's often they do the same stuff. It's often a matter of taste. And sometimes IT integration. Yeah? So depending on whether you work on premise or whether you work in the cloud and which cloud provider you choose, you might choose a different tool depending on the kind of languages you use. Yeah. So if you are a company who is solely R based, you might choose different tools than a company who uses Julia. Or if you want to provide more than one tool, you again need a different path maybe. We opted for supporting Python and R equally as the two languages for data science, and this was one important step to guide our decision on tools that we use for bringing this into production. That both frameworks need to be supported by the platform.
Mm-hmm.
Let me just add 2 sentences on this. There's really no one solution for everybody. There is a solution for everybody, but it's not always the same. It really depends on all the aspects that Daniel has mentioned. And there are kind of so many tools around that you might use, and you really have to check the circumstances, and then you find a solution. But there's no kind of answer that you can give without looking at the specifics of the use cases and of the company and everything.
And it's just, remember, it's just a tool. A fool with a tool is still a fool. So it's not about tooling here, because you can achieve all this without any kind of tool, or almost any kind of tool. Yeah. So they are just helpers, and which helpers fits you best. It's not universally decided.
But talking from experience, when I developed machine learning pipelines 20 years ago for bioinformatics, when we used shell scripts on Linux, I mean, that's a really pain in the ass. So having the right tool makes your life much more comfortable.
It does. It does. But what is the right tool is a matter of choice and circumstances.
Yeah, of course. I think, Rahul, you raised your hand. You have a question?
Guten Abend, Herr Bracht, Herr Schulz. Is my voice audible?
Yeah.
Okay, so I'm relatively new to data science, as I got into it a few weeks ago for a part of a business venture. So my question is more novice level as compared to the others, but it's, at what point do you feel you have enough data to start working on the models? Like, at what point do you feel like this is enough, or you just want to keep going even as you're making the models, gathering more and more data, so you know that you can get the most optimal outcomes?
That's a really interesting question. As a data tinkerer, I say I never have enough data. You can always have more data, but I think a good point is when you start doing your descriptives and you use your signal to noise ratio yields some results. So if it is not blurry anymore, and you can actually from your descriptive statistics, from your visualizations you do, you can start seeing some correlations, some first insights you can actually already challenge with your subject matter experts. Then I would say is a good point where you say, okay, for this kind of data forge, this is enough or good enough.
Yeah. Generally speaking, you need 2 data points at least.
Yeah.
Yeah, and there's beside the empirical perspective, there's also a theoretical aspect. So you can think, if kind of the problem, the business problem that you are going to solve, where data is kind of representing this kind of problem in the physical world on the data level, so to speak. And if you discuss with the data and with the domain experts, or if whether or not the relevant aspects are covered by data that you have at hand, then you can also get a good idea of whether or not data is enough. So is data kind of representing the physical problem to an at least extent, or is there some relevant data missing? From a theoretical perspective, then you can, even before you look into the data, say, okay, we need something more, or maybe you can say it's even completely impossible to solve this issue.
Yeah, fully agree. I think in this process, checking back and forth with the subject matter expert is vital, because they probably know the data much better than you do. As I said, I'm a social scientist and I'm working in a chemical company. I have no freaking clue about chemists, and I have no clue about how a plant operates. By now, I get an idea, but I still have no clue. And they usually can tell you, because they collect the data. They don't utilize the data to the full extent. That's why we are there. We can utilize the data to the full extent, but the subject matter expert knows what kind of data is collected, what quality the data often is. They know at least a little bit, yeah. And so they can judge: do we have all the data we need? Can we actually gather more data? Is also an important question here. Sometimes we want more data, but we just can't. Or what is needed to actually get new data? Do we just have to ask for a different BW query, or do we have to install a new sensor?
There are a lot of more questions on the chat. Maybe we continue with those. There's one question for you, Daniel. Thank you very much. Who puts the created models into production? Is that also the task of the data scientists, or does IT do that?
That is not task of the data scientists, at least not in our company. We have the so-called machine learning engineers for that. So we try to differentiate between the data scientists who experiment, who do the data forges and develop first models, and then we have the machine learning engineers who are excellent in doing so-called model ops. They then operate Kubeflow or whatever tool you choose. They clean up your code that it is actually production ready and stuff. What IT is doing, IT is providing the infrastructure and is making sure that that the underlying hardware runs, so to speak. So it's still and that the ETL pipelines are working. So that is IT task, yeah, that the data is available. At least in our company, it's structured that way. It always might be different, but as Oliver mentioned earlier, it is a very close collaboration between the data guys, aka data scientists, machine learning engineers, and the IT.
And there's one technical question concerning the Miro board, because I think it's not possible to download the PDF presentation. Maybe that's a issue with Miro, because normally you can also download the presentations as PDF, but maybe Afi, if you have an idea how to fix that, otherwise we will just include a link to the download. I think we'll handle this after the event.
We should add the link.
Yeah. Okay, let me check the chat window. So, where is it? Let me. There's one. It's Byron again. Thank you so much. A short follow-up: since the field is just growing and it's hard to keep up with all the fronts, could you recommend some books on the subject? Good point. Do such books exist, or is it mostly learned by doing?
I honestly don't have any books recommendations. Maybe Oliver has. Yeah, I try out a lot of stuff, and I utilize the internet to a large extent. So the problem with books is that they are often outdated very fast in this rapid growing field, as you correctly mentioned. So, and again, it is often also, there is no one size fits all solution. So experience reports by other data scientists and machine learning engineers are really helpful here. That's why I don't have any real book recommendation here.
Yeah. I think there is this one book called Sprint, which is the original one explaining the design sprint approach. I also added a link to the book on Amazon on the Miro board. Maybe that helps to start with design sprints in general.
Yeah, I can say we have used actually a book to get into the topic, but unfortunately I don't have kind of the title at hand, so I have to double check, and I don't want to kind of say something wrong, but I can say that we used a book for getting into the topic, so there are good books around. Yeah. But I can't give you the links here.
Yeah, I will also add a link to an article which I wrote together with Norbert Wirth about how to apply design thinking to data science. And in this article, you find also references to a lot of other articles that explain the topic. So I will add it also to my report. Afiken, maybe you, while I'm doing this, before I forget it, read the next question.
Niall is asking, great core explanation, thank you. A good high-level overview of the concepts. I think key to all this is the consideration of the business process requirements and how any work could potentially fit into the flow of business and its associated ROIs here, unless you want to overfit. Is the question clear? Niall, would you like to add anything? Is it for?
Sorry, hi guys. Can you hear me clearly?
Yep.
Actually, it wasn't a question. I was just saying it's a good high-level overview of the process, and what was apparent with both Herr Bracht and Herr Schulz was that it's important to have the folks that understand the business environment going into this, because if there's no real fit, the data just comes out with something and it's not necessarily in line with what the business wants. So that's all I was saying. It wasn't really a question. And the overfit joke was linked to how much data, because there was a request for at least 2 components of data, but you can always have too much and then you can end up overfitting if you're in an isolated environment. So yes, it was really just a compliment, not a question.
Yeah. Thank you very much.
It's great.
Thank you. I fully agree with your statement.
Absolutely.
So the other question is from Shem. She's asking, sorry, how much data engineering skill set is necessary for a data scientist beyond being proficient in SQL or?
I would say data engineering is, even though kind of there's the role of data engineer that has evolved recently, but data engineering skills are quite important, and sometimes, from my point of view, more important than model building skills. So if you want to improve a model, sometimes it's better to kind of wrangle the data than to kind of change the hyperparameters. So it's a core competence from my point of view, and as Daniel said, like it's most of the time data science is data engineering. So yeah, SQL is probably necessary. I mean, there are other tools for data engineering as well, which I personally prefer, but you need to have some kind of knowledge on data engineering. Absolutely.
Yeah, full support to the statement. I think personally, clever feature engineering is more worth than the best hyperparameter tuning. I think the feature engineering part brings you more in terms of accuracy or whatever your measure of fit is than a hyperparameter tuning. Hyperparameter tuning gives you the last inch, but the feature engineering gives you the mile.
Yeah, good point.
All right, and there are also very other nice comments. Thanks everyone for sharing. If there is no other question, I also, by the way,
we have a question.
I shared in the link an interview query, how the whole definition of data science is also changing. Therefore, feel free to take a look at this interview link that I just shared with you. And Nizam, do you have questions? Would you like?
Yes, I have one question. Like when we think about cloud services, because I'm very new to cloud services, and like what sort of services do we really need to opt in terms of AI and machine learning projects? So if you can give me a brief discussion, a brief note on that, it would be helpful. Should we use the ready-made models that have already available, or I'm really new to cloud, so if you can share some information, it would be helpful.
Yeah.
Oliver, you may.
It's hard to say, actually. I mean, let me put it like this: you don't need the cloud, so you can do everything. You can do everything you want to do with your models without the cloud. But sometimes the cloud helps, especially if you have kind of very fast moving data, very large amounts of data. Then it is helpful to use cloud tools, and there are also kind of some specific algorithms around that are much easier to apply on the cloud. But we have created like data science workflows in the cloud and completely on premise, both is possible. So it pretty much depends, as we said before, on the given circumstances. It's maybe if you say you have just started, I mean, setting up a cloud infrastructure is unbelievably easy. I mean, if you're just kind of writing a script and creating an enterprise level infrastructure in 30 seconds, that's cool. I mean, and if it's possible to use the cloud, I would clearly recommend to do so. But if it's for whatever reason not possible, because your company says, well, you know, the cloud does not have any future, then it's absolutely possible to create a good workflow on premise as well. I don't know if that helped to answer the question, but I did my best.
I'd maybe briefly wanna pick on what you meant with pre-built algorithms. I think we need to differentiate here between an implemented random forest or XGBoost, which is not inherent to the cloud. I mean, those algorithms are implemented in Python and are just the same. So then you are still implementing algorithms. The other thing, and I think this is a whole different topic, is because you mentioned Azure, it's this whole topic of AutoML. So let the cloud or whoever choose the algorithm for you. Especially when you just started with data science, I would advise you not to do this because data science already is prone to be a black box approach. Putting then some AutoML on top is even more black boxish. And in my opinion, this is not a good learning path then, but that's just my personal one. I think you should at least have a ground understanding of what is going on in this algorithm, or what algorithm at least is used. I mean, I can't explain you the details of a neural net, but I know when a neural net is used because I applied it. But if I only choose out AutoML, I don't have a control what kind of algorithm is used. But for the learning path, I think cloud is just fine, as Oliver said. I think we have to differentiate those two topics.
There is a good book, I couldn't find it. It's called Deep Learning with Python, but one of them, there are multiple of them. I will find and add it to the Miro board as this handout. It's very nice overview of a comparison between different services, different cloud functions, and kind of a quick, fast prototyping starter, kickstart kind of thing. So this can possibly also help.
I think we should come to an end because people, I mean, a lot of people already said goodbye on the chat or just quietly left because I think it's late or even later in India. I have a question for you guys still watching us. And I have 3 questions and please answer them on the Miro board. There is another box on the Miro board. It's titled feedback, and the 3 questions we have is: what did you like? What didn't you like? So what could we do better? That's I wish. And the third thing is I do. So what are the key takeaways for you? What will you do differently tomorrow? What will you start doing tomorrow? I think that's for us very important to get your feedback. So yeah, we can integrate it into the next DataBrain meetup in March. And I will send you the link to the Miro board again on the chat window. Here it comes. Already giving us feedback. Great, thank you very much.
Thank you so much for everyone participating.
Especially thanks to our speakers, Daniel and Oliver. After a long day, I think you also had a lot of video calls, and then even in the evening, another one for 1.5 hours or even longer. Thank you very much.
But that's probably true for everybody here. So yeah, it was a pleasure to be here. I think it was a very interesting discussion. So yeah, it was really fun. Thanks for having me.
Thanks for having me. It was great fun. And yeah, talk to you soon at the next meetup, or if you want to hook me up at LinkedIn and need some further advice, just do so.
And one last TV tip or YouTube watch tip. Today, the Mars Perseverance will land on Mars, of course. Therefore, in 2 hours a bit. So stay tuned.
Thank you. Have a great evening.
Again, everyone.
Bye.
Bye. Stay tuned.
Thank you.
See you
Thank
next
you.
time. Thanks to you.
Thank you. Bye-bye.
Thank you. Bye.